Life after code in place is limited to those who are 18 years or older. If somehow someone under 18 is here, we ask that you leave now and watch the recording that'll be available before long. So there's no attendance, no grades, no certificates, recommendations. This is just purely for the love of learning, but with a somewhat smaller audience. We encourage active participation here. We'll give out some resources afterwards. Some are already available. Also, you can use the forum. We ask for professional conduct as always. So last week we looked at dictionaries. This week we'll talk about data, NumPy, and pandas, and some charting. Next week we'll use those tools in giving a brief introduction to data science. And both this week and next week, we'll give out a collab that you can make your own, you can customize, you can share. And thanks to some volunteers, there are other things available this week. 23 hours from now, Martha will have some office hours for anyone who would like. 36 hours after that, she'll do it again. There are some videos either available or coming up. Coding demos, 6 days from now, thanks to Vicky, the Pie Whisperer. And 1 week from now, again, we'll have a session on data science. So today, we will work with Google Colab. So in order to get access to the Google Colab, log in. Let me drop this link in the chat. So log into Google, like your Gmail or what have you, in a browser, and then open up a different tab. Take this URL that I dropped in the chat and access that in a different tab. So for example, I've copied that, and then you can copy it, save it, rename it, change it, share it, download. This is the same one that is in the code in place announcement. Yes, the same URL, same collab.
Doug, when you say open it in a different tab, just open it in a different browser, right?
Well, it needs, like, for example, I say a different tab. Like, for example, I've got in my Chrome, I'm logged into some account. So I open up a different tab. Like if I went into Firefox and I'm not logged into Google, it won't work. But if I go to somewhere where I'm logged in to Google, and so I copy this, drop it in a tab, and
Right.
there we have it.
So, so once you're here, what do you want us to do? Do you want us to save a copy or
Yes. So right now, for everyone except for me, this is a read-only version. Okay, but now what you can do, you can hit File, save a copy in Drive. Okay, so that'll give it a different name and create a copy in Drive. And let's say, and then you can rename it. Rename it like, you can call it uh well, like I could call it Doug LACP week 4. And then now I have my own read write version, and the changes that I make here are under a different URL and will not affect the copy that you all have access to that via that URL.
okay. Um, but our copy will be saved onto our own Google drive, not your drive, so that you're not gonna get like 30 copies of various people's um
Correct. Everyone will have their own copy, and it's less than a megabyte
got it. Okay.
space. And then later, if you want to share it, th- there's two ways to share it. One is with the share button, like I could just give certain email names here, just certain friends, or like I could share it with everyone at San Jose State, or I could share it with everyone who has the link. And then if I wanted to put it on my CV or send it to all kinds of people, I could do that then by sharing this link here. The other way to do it is file, download, and download the .ipynb file. And that'll drop a copy onto my hard drive. It's less than a megabyte, so I have it saved that way as well. So there's two ways to share it.
Um, Sorry, one other question, because I know in Jupyter Notebook it can be knit into an HTML format and then displayed as a um like online on a web or something. Can you do it with this?
Let's keep things simple and let's just have, we already have two ways of doing it.
Okay.
Um, let's just focus on, short answer is I'm not sure offhand, but
Okay.
let the traditional ways of sharing it are through that or or by downloading the IPYNB. And just as a quick review of Colab, in Colab you have two types of cells. And to access a cell, these borders for a cell, we have code cells and text cells. So when you get on the border, it allows you to make a new code cell or a new text cell. Here it would make it before this first cell. And here we can make a code cell or a text cell after this cell. Or we could edit this cell. Let's say we edit this cell, and it shows the markup here on the left and on the right of what it will look like. Let's say, okay, I'm in a really excited mood today. I want to have a bunch of exclamation marks here. And then we close it so that that little change has been reflected. And then if I were to share it now or download it, the next time we see it, it would have that. So again, the key things here, you can save a copy in Drive, you can rename it. You can also, and if you have a .ipynb file, then you can upload it. That means upload, grab a .ipynb file from your hard drive or whatever and run with that. So to get started, you could use a URL or a .ipynb. And once you're done to share it, you can share it over here with the share button to share a URL, or you can download the .ipynb. And in the meantime, you can rename it and you want to save it before before you rename it or share it. And again, we have code cells, you just say print hi, and then you click on this run. It takes a few seconds to connect. So this runs in a Google Cloud somewhere, and then it will actually execute the Python. You can add a text cell. Hi everyone, and you can use the markup here, bold this, italicize that. Then when you close it, you have it. You can edit it, and if you're like, okay, that's nice, I want to delete it, you can move it. Let's say I want the text cell above the code cell. You can move it up, and then you can say, okay, this code I don't need anymore. You can delete it. So let's look at NumPy. We've, in recent weeks, we've looked at lists and dictionaries. Lists and dictionaries are flexible. You can have a list that contains strings, integers, floats, booleans, all in the same list. That's very nice flexibility on Python's part, but it makes for the code running very slow. In data science or AI, in real life, we're typically dealing with large volumes of data. We don't want to be too slow. With NumPy, NumPy creates arrays. NumPy stands for numerical Python. It's basically the backbone of one of the backbones of data science and AI, and Python provides arrays which are relative to the rest of Python very fast, highly efficient. Now if you have a list, like I said, a list can have all kinds of things in it, strings, floats, a NumPy array, everything needs to be the same. All strings, all ints, all floats. And that enables Python to make it quite a bit faster. But first things first, we need to import the library. And in a collab, you can run the code cells one at a time using this. You can also do run all here to run all of them. So the convention is to import NumPy as NP. Theoretically, technically, you could import it as anything, but the convention is it's always done as NP. If you do something other than NP, people will kind of think you've got really strange code. So please always import it as NP. And a one-dimensional array is is like a list of numbers. Now here we have a list. Remember the square brackets? That's a list. This is Lists are relatively slow. Not that it matters when we have 5 items, but here we can make it into a NumPy array here. Temperatures is a NumPy array. And if we use the type to look at this, it's not a list. The type of this is numpy.nd array, n-dimensional array. Most of what we'll be talking about today is a one-dimensional array, but NumPy can support two-dimensional, three-dimensional. You can go more, you can go crazy. So this one thing that's very nice is you can do operations on a whole array without without having to loop through and do it one item at a time explicitly in your code. This is, for those who joined early, this was Dieter's question about vector operations. Um, so here we've got this NumPy array, this n-dimensional array, temperatures. It's got these 5 items in it, and the temperatures vary. They start at 21, they go up to 25. Warmer temps equals temperatures plus 2. This is a nice feature of Python, of NumPy. You can add 2 to an array. If you try and do that with a lot of languages, you'll get an error. This will create a new array of warmer temperatures. So if we run this, what did I do? I probably forgot this. It was relying on this having been created, and I had not created it yet by running this. So now the original array, the temperatures range from 21 to 25. This new array, warmer temps, by adding two, it adds two to every single element in the array in an efficient manner. It's much more efficient than looping through and doing it one at a time. Similarly, here we make another NumPy array called Fahrenheit. This takes the temperatures array, multiplies each temperature by 9 divided by 5 by 1.8, and adds 32. And then when we print that out, we have the Fahrenheit temperatures for, for the original temperatures here. Uh, there is a way to create, it doesn't have to start with a list. You can, to answer Primo's question, you can do something similar to that. There is a way to do it with numbers. But here it is, Primo. Um, this is how to create a NumPy array. So we start with the brackets here, which is the syntax for a list. NumPy array is a function which says create a NumPy array, put it into test scores. So we have test scores here, and NumPy has a lot of nice mathematical capabilities to it. You just take a NumPy array and dot max, it'll show you the maximum value. Dot min, the minimal value, the mean value, the sum. Uh, so we run this and we can find the highest value, the lowest value, the mean, the class average, the sum of all these. It's also, so it's got a lot of powerful mathematical features built right in. So you don't have to do these things in loops. Now we can also do filtering as well. So here we create an array of ages. We have these 7 ages ranging from what, 12 to 40. So we want to make a NumPy array where the age of the ages of people who can vote. We don't want to have this. So we can create ages ages greater or equal than 18. So if you take each element and see is it greater than or equal to 18, it will create a bunch of Booleans. The first one will be false. This is not greater than or equal to 18. The second one will be true. This is greater than or equal to 18. And so when we print this out, this can vote, we've created an array of 7 Booleans. When we print it out here, we get false, true, false, true, 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 false, false for the last one, mostly true. And this is nice. Look at this syntax here. This creates a NumPy array starting with this array of 7 items, but it only creates elements for those that are true. This is an array of 7 Boolean values, true and false. 4 are true, 3 are false. So the 4 that are true are created right here. So this is a tricky little bit of code here, but it's pretty powerful. Yeah, good question, Vicky. So let's focus on um the 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 traditional aspects of this on the way things are generally used. Vicky's question brings up the point there are a lot of capabilities with with NumPy arrays. We're not going to get off and discuss all of them, but we want to give you a general overview of how it is generally used. So this this is a tricky, there are two tricky things that are going on here. One is this line here creates a NumPy array called can vote, which has 7 Boolean values, true or false, depending on whether the first item is greater than or equal to 18, the second item is greater than or equal to 18, etc. And so any questions on that, first of all? Okay, and the next question is now we've got this NumPy array of true and false. We can have that within square brackets here, and then it'll create another NumPy array, which will only copy the original values of, of this array based on which elements here are true. So 4 of these are greater or equal than 18. So 4 of these are true. So this line here creates a new NumPy array with only 4 values, the values that are greater than or equal to 18. And when we print it out, we get this here. Questions on that at all? Okay,
Yeah,
now, question?
yeah.
Go ahead.
Uh, I wanted to ask, in which, how, maybe, sorry, maybe if I missed something, but how is it different from, in which sense this arrays from NumPy is different from the list of Python? I think, can the list of Python operate the same functions as the array from NumPy?
Right. The focus of NumPy arrays, the the intended use of it is for numerical operations. And the benefit of it is lists have huge amount of flexibility, but they're pretty awfully slow. NumPy arrays is the use case for them is to use them for numerical operations and especially with large amounts of data. NumPy arrays are dramatically faster than lists, which doesn't matter if we're dealing with 5 or 40 items, but if we're dealing with thousands of items or a million items, if you try to do that with lists, it's not practical. Whereas NumPy arrays can give you this flexibility, give you this mathematical ability, and are relatively very fast for Python. And that's why data science and AI use NumPy arrays heavily, because data science and machine learning and AI tend to be dealing with huge amounts of data.
Yeah, okay, thank you.
Sure.
Question answered. Yeah.
So now here we can also just generate arrays. So this will give you a random array of integers from 1 through 100, give you 5 of them, and put them in this NumPy array. And it'll print that. We can generate an array of 10 zeros, an array of 12 ones, an array from 0 through 9, an array of 2 through 19, every third number. And we print these out. We got the zeros, we got the ones, we got the 0 through 9, we got the 2 through 19, every third number. So generating initial an array with these initial values can be done with one line of code at, and again, NumPy arrays are relatively very fast. Questions on any of this?
Sorry, why are you saying relatively?
Well, it's not going to be quite as fast as, say, as C or C++ or assembler language, but the beauty of Python is it's a lot easier to code than, say, C++. It's got all these nice capabilities that are right within the language. And that's why, Python is very heavily used today in general. But the reason why, but Python is not known for its speed in general. Like if you're working with lists or dictionaries, if you compare that to C++, it's going to be painfully ridiculously slow. But NumPy arrays are probably not quite as fast as C++, but relative to the rest of Python, it's very fast.
Now, doesn't Python, in this case, use C++ behind?
Yeah, yeah, it's
But
underneath.
why it is different speed?
Well, it's still Python.
Ah, okay. Makes sense.
Um, Now, we've just looked at one-dimensional arrays. Let's just look very briefly at two-dimensional arrays. And I'm going to cover this fairly quickly. But so here is one way to create a two-dimensional array. So conceptually, it's like creating a one-dimensional array, but instead of individual items, you have what looks like a list here. We've got student one, which looks like a list, student one score, student two score, student three score. We can print the whole grade book, and we have these two square brackets that indicates two-dimensional array. And one thing nice, we have this dot shape property, which actually gives us two things. It gives us the number of rows and the number of columns. And if we want to look at a specific item, like let's say we want to look at um, row one, column two, we would look at grade book. Remember, we start with zero, so row what it zero comma one, that will tell us give us the row one, column two, this 90 here, this 90 right here. So this is the syntax for accessing an element in a two-dimensional array. You've got the comma in there. The other thing of note is the number of dimensions. Like if you get an array, someone passes it to you. If you want to know, is this a one-dimensional array, a two-dimensional array, a three-dimensional array? This property here will tell you the number of dimensions. And then I always get confused whether it's length or size. Okay, it's not length. I go back and forth between too many languages. So the size here is the number of elements. So number of elements is the size, gives you the total number of elements. So there are 12 elements total. So I went over this probably way too quickly, but I don't want to spend too much time on this. I just want to show you briefly how to deal with two-dimensional arrays, or by extension, three-dimensional arrays. If you want to get more into this, you can study it on your own. And one thing I would encourage you, if you're trying to understand, let's say later you're trying to understand this, I think the best way to use AI as a teaching tool is not to give me the answer, say, try to do something with a two-dimensional array, and instead of asking AI, what's the right way to do this, say, what concept am I missing here? You can use AI as a tutor. So anyhow, the main three libraries that are used heavily in data science and that we're going to talk about today are NumPy, which is numerical Python for arrays, basically. Pandas, which has this very popular data structure called a data frame, and charting. We'll just look a little bit at charting at the end, basically just to show you some of the capabilities there and to let you see, give you an example, some examples you can play with. We'll cover that very, very quickly, but this data frame is is a key structure that is used in data science, machine learning, AI. It's very popular. So these are the three packages you really need for data science typically. They're also a subset of what is used in machine learning and typically AI as well. So we've talked a little bit about NumPy, and that'll give you arrays. Now, Pandas is a Python library used for data analysis and manipulation, and the most popular data structure within it is the data frame. And you can conceptually think of a data frame as like an online Excel spreadsheet or a table in a database. It's got rows and columns, but it gives you a lot of nice ways to slice and dice and manipulate it and work with it in relatively friendly ways. Anyone who knows databases somewhat knows that working with tables, there are a lot of capabilities in databases, but to do it like in SQL or in whatever way is requires a lot of expertise. It's pretty painful. You've got a lot of capabilities with databases, but I mean you have people whose careers are databases to to work with that. And Excel spreadsheets have rows and columns, and there are ways to manipulate it, but it's pretty awkward. Data frames, the reason they're so popular, the reason they're used so heavily in data science and machine learning is it's relatively, um, you got a lot of capabilities that you can do without a huge amount of expertise and without having to write a lot of code. Okay, enough talk. Let's get into it. So let's say we have 5 students. We got their names. We've got the scores on quiz 1. They have these 5 scores out of 20 points. Quiz 2, they have these 5 scores out of 20 points. Let's create a data frame, kind of like a table, to organize this data. Each row is for one student, and each column is for one category, specifically quiz 1 or quiz 2. So we import pandas as PD, and again, PD is what is used throughout the whole industry. So please use PD. If you use something else, people will will wonder, where did you learn how to code? Um, so here we've got 3 lists. We could also use NumPy arrays. A list of the names, quiz 1 scores, the quiz 2 scores. Now we create a data frame with these 3 lists. Students, this is the data frame. Another nice thing about Colab, if you double click on a variable, it'll tell you what it is. It tells you it's not only it's a data frame, but it's got shape 5, 3 rows, 5 rows and 3 columns. So now students is this data frame which has these rows and columns. And instead of using print, for the convention for data frames is we use display. It'll display it relatively nicely. It'll display it in an appropriate manner for data frames. And here it shows, again, we have the zero index. This just shows what number it is and zero base, but it shows we have these names. So Emma on quiz 1 got an 18 and quiz 2 got a 19, rows and columns. So we use the brackets for the input, or we could use NumPy arrays or lists. But then we create this data frame here. Now let's add a column to this. Let's say later in the class we have a quiz 3 and we have these scores. So here students is the data frame. We're going to add a new column here with these scores. If we display it, now we see quiz 3 has appeared. And we display it. We have now we've still got the 5 rows, but we have 4 columns instead of 3 columns. So cover this pretty quickly, and we'll get into more of the capabilities of data frames. But any questions on this so far?
Just a quick question. The leading number 0, 1, 2, 3, 4, they're not part of the element. It's just like the other thing we did, like the enumeration thing. Is that
Yes,
right? Yeah,
right.
okay.
It's just for our benefit. So
Okay.
yes.
Thank you.
Yeah, and data frames can the nice thing about data frames is you can have the columns you typically want to all have the same values, but you can have a column here, quiz 1, quiz 2, quiz 3 could be integers. You could have floats. You could have another column, say grade, A, B, C, D, or passed, true or false. But this is nice. We can create it. What if we want a data frame with millions of values? We're not going to type out millions of values here, right? How will that work? Well, data frame can create data from a file. So here we have a file. Here we have here we have a URL. So this is a CSV file, CSV comma separated values. It are very standard type of files used in computer science. Like if you if you export an Excel spreadsheet, it is often a CSV file. Now, if I take this URL, just let's look at the CSV file. I think I've already done it here. And I paste it here. Here is what the CSV file looks like. It has these headers, kind of like the headers of a column in an Excel spreadsheet. And then it has these values. There's rank. This is actually part of the data. Then a name. So these are NBA salaries. So we got the name, we got Shaq O'Neal, position, team, Los Angeles Lakers, and the year. And in the year 2000, Shaq was the highest paid basketball player in the league. He made $17 million. Yeah, and this is why we do not want to work. To Steve's question, isn't this hard to print out? Well, this file has over 9,000 rows. So how do we work with this? What if it had 1,000,000 rows? You can't deal with that, right? So this is a string here, which just says this URL. But here's the magic line. Look at this. In one line of code here, this tells pandas to read the CSV file, go to this URL, grab this URL from the internet, read it in, and put it into this data frame called NBA. So we look at NBA. This is a data frame. And if we then we display it, again, display basically prints out data frames, or not the whole thing, an appropriate view of a data frame. Now, we don't want to see 9,000 rows here, right? But it shows us the first 5 rows, 0, 1, 2, 3, 4, and then the rank. So the first record here shows that Shaq was the number one highest paid player in the NBA in the year 2000 with a $17 million salary. And this is salary data. This file has salary data for 21 seasons from 2000 to 2020. And the last item.
I have a short question.
Yes.
About this ranking. We didn't put what kind of data should we rank? That could be season. Why did you decide to rank the salary?
This was part of the data. The data, that CSV file already had for 20 seasons, not only had Shaq's name, but he is the number one ranked, the highest salary in the year 2000. That was part of the data. This just shows us the row number for our benefit. This is not part of the data frame. This is actually part of the data. Yeah. So, and when we do this display, it's smart enough to know, okay, they don't want to see 9,000 some odd rows. It shows us down here, we got 9,456 rows and 6 columns. Row 900, the last row shows that the rank, this is the lowest paid guy in the year 2020. This Canadian guy, who most of the year was in the minor leagues, made $155,000 in the year 2020. Don't worry, he's making 100 times that now. He's turned into a good player. But this display shows us typically the first 5 and the last 5 rows of a data frame, so we can see what's there. I mean, you can take it on faith that this worked, right? But it's always good to see the data and see what's there. So the CSV file is stored online, but again, with this one line of code, it read this in from the internet and created this data frame called NBA, which has these, in this case, 9,456 rows and columns. And it'll take care of figuring out, okay, this is a string, this is an int, something else could be a float or a double, whatever. It'll figure all of that out. So that's nice. We have this data frame. How do we figure out what is in there? Yeah, and it's a lot of times there are ways, if data is missing, you can default the data. Same thing with NumPy. So maybe I forgot to do that. There we go. And then the shape again returns 2 things, the number of rows and the number of columns. So we can print out the number of rows and number of columns. And what if we want just this head command says by default, if you give it no parameters, we'll show you the first 5 entries, but you can show the first 3 entries, say, or the first 30 by putting a 3 or a 30 here. Tail similarly will by default give you the last 5 columns, or if I want the last 6, sorry, the last 6 rows, this will give you the last 6 rows. What if you just want to know the names of these column labels? I mean, if we got 6, you can just see them. What if there's 60? Well, you can get the columns to list and it'll print out the names of the column labels. Yeah, and if you don't, one way to clean the data is you could make, if you don't want the defaults to say to be all zeros, there are ways to see which ones are present or not. So you can eliminate some of those. That's beyond the scope of what we'll talk about today, but to Teresa's questions, you can use some of the capabilities with data frames to eliminate data where you've got missing values or you've got 0, or you can look for NA. There's a lot of ways to filter. Now, let's look at common ways to access data for a specific column. So this data frame name, like our NBA, we can see NBA dot column name, as long as there's no space in the column name. You can always do the name of the data frame, like NBA bracket quote column name. That'll work even if you have a space within the column name. Or you can use the column index. Like if you want the third column, you just say colon, comma, 3. So so let's say all we care about is the salaries. We just want this one column. So salaries, we can display that. And now salary just has all these numbers. And it's got again, we've got these, it's basically a data frame of 9,000 some odd rows in one column. We can also get multiple column names with commas. Okay, so what will we print if we take NBA dot iloc colon 3? Any guesses?
Teams.
Yes, exactly. It'll print the fourth column. The fourth column. So it will create for the this will create a data frame of 1 row, sorry, 9,000 some odd rows, 1 column with all of the team names.
Question. The colon in the square brackets, what does actually that mean?
Uh, that's just the syntax for this. I mean, you you can get more complicated than this, but this is the default. If you just want to reference a column by the number, this is just the syntax for that. And so here, this will just get the salaries, the last 6, and you can chain these together. NBA.salary gives you all the salary information, but this says I just want the last 6. So here in one line of code, we can take this whole NBA data frame, get the last 6 salaries, and we'll display it. And here's the last one is the salary of that Canadian guy, Dort, with the lowest salary of 2020. So that's called function chaining. You can go crazy with that. You can do more than two, and it's actually an acceptable practice. The first time you see it, it looks a little weird and complicated, but once you get used to this syntax, NBA.salary, and then the tail, you could even do another one or two after that, and it's considered good programming practice. So how do you get a specific one? So let's say you want the third the third salary, third the third row, the fifth column, you do it like this. And it gives you the third salary, just that single value. So again, three ways to access data for a specific column. You can just have the column name, but here you can have the column index.
I have a question.
Yes.
So this first item, it's quite interesting. So this column name is kind of automatically created variable based on in what the name of this column or what?
Yes. 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 But again, you can programmatically right here get the names of the columns. So you don't have to know them ahead of time. This columns to list can give you the names of the columns.
Yeah, I understand about names. I don't understand about variable. So
Right.
variable is something predefined, right?
Right. Right. Well, this is just a a capability that data frames has. Yes. It's 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 pretty convenient. It's pretty unexpected. It's pretty nice when you get used to it. Yeah. There's a lot of capabilities here. So name is a column. So we can just say on that initial data frame where we had five people, students gives the name column for that data frame. So now we have a student's data frame with only one column basically and five rows, and it gives us those. So like NumPy, data frame has a lot of mathematical capabilities here. So let's say, you know, these salaries with 8 digits are hard to process. You get sick of counting zeros. Let's say I just want to know how many $1 million these players are making. This one line of code here will create a new column in the NBA data frame, and it will for every row, it'll take the original salary and divide it by 1 million. So the first row here, we have Shaq's name. Remember, the last column was season 2000. His salary was, after you count a bunch of zeros, you figure it's 17 point something million. This line of code creates this new column, 17.142, but it does that quickly for all 9,000 some odd elements. So it creates a whole new column for every single row with right here like this. So it's pretty nice capability. So then we've got this new column here. And a lot of times, like, okay, we pulled this CSV file and we've got all this data. Well, realistically, we only care about some of it, and we can drop columns as well. We can add columns. We can sort as well. So here we've got the data like this. Here's the first five. It's like, well, I don't want it sorted by salary. I want to sort it by name. So this creates a data frame of the first five entries. So we got Shaq, these five players from the year 2000. This sorts them by name. Name is a string, so Alonzo A is first and S for Shaq is last. So they're sorted by the name column. And by default, it's ascending. You can just add another parameter to sort in descending. So again, here's the first five rows. What if all we care about is name and salary? We don't care what team they're on or what year it is or what position they play. We can just look at this syntax. We've got the two square brackets. And then, so this gives us for all 9,000 some odd players, we just have the names and the salaries, and then we just show the first five here. We can also create NumPy arrays from this. So here we have this salary array, NBA.salary to NumPy. That'll create a nice fast NumPy array. If we print the salaries, print is smart enough not to print 9,000 salaries. It prints the first three, ... and the last three. But here we see here that the type of this is a NumPy array. And so you can explicitly say which columns you want, or you can explicitly drop columns here. Another way of doing this is I want to drop the rank, the position, the team, the salary, the season, which only leaves the name and this one new column that we created. And also you can select specific rows. There's multiple ways to do that. You can get a new array by the row index to NumPy. You can get a range of rows and specific rows. So I'm covering this quickly, but this shows you some of the capabilities that are there. And you can go back on your own later and work with this if you want to look at these a little more carefully. Here's another example by the range, you can get the 5th and the 10th values. You can slice and dice it in a lot of different ways with very, very little amount of code. You can also conditional selection. Let's say I don't care about anyone but the Golden State Warriors. You can only get the values. This will filter out the whole NBA data frame and say, only get the ones where the team is the Golden State Warriors. So instead of 9,000 some odd entries, it shows us the 311 that are for the Golden State Warriors. So there's a lot of, or if you only care about certain seasons, the last two seasons, 2019 or 2020, you can filter that way as well. What's nice about this, one line of code, you've done a lot of filtering. If you were to try to do this in, in an Excel spreadsheet or in a database table, it's possible, but it's pretty painful. And you can filter by, I want only Golden State Warriors and the season is 2020. I only care about these two teams. You can um, look for a partial match of a string. I only care about the position is a guard. G means guard, P is point guard, S is shooting guard. I just want any of those. I don't care about the other positions. You can do case sensitive or case insensitive filtering. So I went through that pretty awfully quickly, but this gives a good feel for some of the capabilities here. And if you want to play with this on your own, you can. But again, NumPy and data frames are core technologies that are used in data science, machine learning, and they allow someone without having to write a lot of code to do a lot of nice filtering of data, and it's relatively efficient as well. Any questions on this?
Hi, Dog. Can you use the index to filter the data, or does it have to be like a specific column?
Oh, yeah, I mean you could do index is not equal to. You can filter. There are so many ways of filtering. I've just showed a few of the examples. Absolutely. We're just scratching the surface here. You could say not equal this. There are many ways to filter. You could absolutely do that.
Hey Doug, I have a quick question. And so when I look at this Google Colab, there is an AI function you could get help with um from, I guess, like AI. I'm just curious, do you know, because it's Google, is it always getting help from Gemini, or can you specify if you have your favorite AI, such as, if I want to use ChatGPT instead of Gemini or Claude instead of Gemini?
Inside of Colab, it is a Google environment. So inside of Colab, uh, it's Google only.
Okay.
Now that said, you can feed outside of Colab, you can feed things into ChatGPT. It knows about Colab and it can do some work on it, but that would be outside of the Colab environment.
Okay.
So now let's quickly go through the other thing that's used a lot is charting. And I'm just going to go very quickly through that in the interest of time. The three main capabilities in data science, we looked at NumPy, we looked at data frames. Here's the other import for charts. You can get all kinds of charts with this line of code. Okay, and so here, there's a lot going on here. This will give us some random numbers. List of random numbers is in the variable x. Y1 is some random integers from 10 to 50. And Y2 has some random integers with a mean of 50 and a standard deviation of 4. That basically means the numbers center around 30 and they vary not too much from 4. If we increase this number, the numbers would vary further from 30, and we get 50 of them. Categories gives us some strings A, B, C, D, and values gives us a list of these 4 different numbers. So we will try to just keep these variables in your head. We'll use these quickly showing some of the capabilities of charts using these variables. So here we're plotting X and Y1. X is just from 0 to 49. Y1 are these totally random integers, and Y2 are these random integers that tend to center around 30. So, and we'll print 2 line charts here. The Y1, these are these totally random numbers from 10 to 50, and Y2, which center around 30. So now we print these, and we've got this chart here. This is made up data. I mean, we made up this data right here in this code cell, but without much code, we've got a nice line chart example. It shows in the blue, it shows Y1, these totally random numbers, and Y2 are these random numbers that center around 30. So the second series, they're centered around 30. The standard deviation is 4. If you know what a standard deviation is, it gives a feel for how much they vary. But what's nice about this is you need this without much code, you can do this. And I'm not going to go into the details of this. You can use this as examples. Just want to go through some of the capabilities of the charts. And Dieter just put a good resource in the chat. Now, here's a scatter plot. Now, Y2 are those data points that center around 30. This scatter plot might not be that interesting. Let's look at a bar chart. What's this, 7 lines of code? We've got a bar chart showing those 4 categories and the 4 values. So what's nice about this is we're doing all this slicing and dicing of data in the data frames. You can use charts. Instead, here we're just showing fake data, but you can use values that you get from your NumPy arrays or your data frames and show them in these nice little charts here without having to do a lot of graphics processing or whatever. We even have these 3-dimensional bar charts. Now they're not always that useful. That's I'm just showing you that it does have this capability. That's not always that useful. But here's a histogram. So we look at the chart, do the histogram. We can specify the edge color, the number of bins shows how many bins to have here of those values. Let's say we don't want to combine as much. We want a larger number of vertical bars. Well, we can say bins equals 20. We can make it yellow We can make the edge color red. And just by tweaking this, we've got a much different view of the data. It's like, okay, that's maybe I want only 5 bins. And in real life, like let's say you want to show this to your customer, your boss, your teacher, your friends, you'll typically take here's what I do. We take an example like this, print out something, say, oh, I don't like that. I want and have to ad adjust the parameters until you get the view that you like. But what's nice here is without knowing a lot about graphics programming or a lot of this, with an example here, you can get the idea of how to adjust things. This is the data input, and with what 6 lines of code, we can actually get a decent looking histogram here. And similarly, so this is a pie chart using values. Remember, values are just those 4 numbers. And then the labels are the categories. So the categories are the A, B, C, D, these values for those 4 numbers. And now we've made it into a pie chart. So this is just a very quick look at some of the charting capability that you can use without being an expert at graphics programming, which, can be this huge investment of time. It used to be, it was this decades ago, there would be whole professions of people who are into graphics programming. Here, relative amateurs without much code can do a fair amount of nice charting. We've looked at how to use NumPy today to use numerical processing of arrays. We looked at data frames, which is kind of the core data structure used in data science and used heavily in machine learning as well, and took a quick look at some of the charting capabilities. So any last questions on any of this? So again, let me remind you. So I made some changes here while we were coding, right? I want to rename this I don't know, Doug Final. You can and then I could save it. And then if I want to share it, I can share it, click on share. I can share it by email address. I could restrict it to any other teachers at San Jose State, or I could share it with anyone and everyone by clicking on this. And then I could copy the link and do whatever with it.
Doug, we've got a question from Igor. He raised his hand.
Oh, okay. And then I'll get to that in a second. Then
Okay.
again, the other way is just to save it. Let's say I want to use it again next week. I can download it as a .ipynb file. This one is less than a megabyte. That again shows the main ways to work with these, share these, download these. Question?
Is there a library similar to Matplotlib, but to do such visualization with maps? Or maybe does Matplotlib allow that?
I There are so many open source types of, I'm sure there is. There in general, there's a lot of and I know someone who's working in that area who so yes, the answer is yes. Now, the thing to be careful is some of these open source packages are better than others. Some of these only kind of work, um, but there are literally thousands of open source packages that do all kinds of things. The key is finding the most commonly used ones that have been around for a while that you know work pretty well. But if you're looking for something very specific, even if it's not been out there that long, it might fill your needs. So there are so many packages you can use and import. The trick sometimes is finding the best ones, but it's good to, where possible, use the ones that have been around for a while and are heavily used. So yeah, let me share the link for this if anyone wants this latest and greatest with the changes. And again, let's go back and look at some other things that are coming up this week. So we've got Martha's office hours tomorrow and Thursday, California time. There's some coding exercises posted. We've got some coding demos coming up 6 days from now, courtesy of the Pi Whisper. And 1 week from today, we will look at using some of these NumPy data frame and charting technologies in an introduction to data science. And again, there, I will give you a copy of the Colab so you can play with, adjust, and make it your own with an intro to data science. So thanks, everyone. Appreciate your time today. And a lot of this stuff will be posted, and hopefully we'll see you next week. Thanks, everyone. Bye-bye.
Thanks.